Hello, welcome back. Now we are going to talk about traffic analyzer settings. And let's go to our virtual machine. It's important to note that we are going to configure our files to execute the training, executing the training of our network, of our neural network. You configure to get our training data for our network. So to do that, first of all, I have to create a folder named output in desktop, and inside that folder we have to create a file called simul_conf.txt. Okay, and we have to extract this file as I will show to you. Let's take a template here. Okay, here we have a template. Let's copy this template. Okay, great, and let's paste it in our conf file. So here we have the settings of the traffic analyzer. The first one is CC, that's the congestion control. We have set it to TCP Vegas, as we have in our article. I will show you. So these lines are taken from the article. Okay, TCP Vegas. This is a piece of this article here. It's important to remember that. We are basing our activities. So the first one is the congestion control. We are setting. Now we have the simulation time. That's in seconds. In seconds here. You can see in our article we have 1.5 minutes. That is 90 seconds. As we set here. Great. So the next one is the number of flows. Here we have flows. For training data, we use 6 flows, as you can see here, this piece from the article. Okay, again, let's again, oops. Okay, so this 6 flows, as we have 6 flows, we have 60 clients and 6 servers. Now let's go to start flows interval. That's the interval. The flows will start one by one. Okay, we can see in this line here, connections are spaced with 0.5 seconds. That's when a connection starts, the next one will wait 0.5 to begin. Bottleneck data rate is the data rate of the bottleneck. Here we have our bottleneck. So we are taking 100 as an example, but it's important to note that we made this configuration for each one of our considered bottlenecks. So here we have a router queue. It's the router 1 queue. Okay, 300 packets, as we can see in this piece from our article here. That's the queue size of router 1. Okay. Training data. Max random time for new TX. This is the time that the client waits to fill the socket buffer. So when we have space in socket buffer, the client will wait a random time of a maximum of 70 seconds, as we can see in this piece from our article. Okay, in our article, this things is explaining in detail. Training data, we are telling to Traffic Analyzer that we are going to extract training data. If you extract generalization data, we have to put 1 here and 0 in training data. But we'll talk about generalization data later. Okay, so let's go to the next one, the intelligence. It's to tell Traffic Analyzer if some classifier is active. So for training, we have no classifiers working, so we put 0 here. It's a bool variable. Okay. Next we have neural network architecture. Is the architecture from which the classifier come from, and the classifiers come from we have in this case 4, that's LSTM, ACK, and RTT, as I will show you. The first 3 ones, MLP model, LSTM model, CNN model, is using the 3 metrics, ACK and RTT, and we are varying the architecture and the metrics like like indicated in this first column of this table I am showing you, and the corresponding number is on the right side of each one of the RNN architecture. Okay, so as you can see, we have LSTM, ACK, RTT is the 4. But again, for training data, we don't use that because the intelligent parameter is set to 0. Okay. Okay. Intelligence is 0. Now you have bottleneck bear. It's the bear of bottleneck. Here we don't use that. For training data, the bear is set to 0. We'll talk more about that later. Okay. Here we have, I will show you how the traffic analyzer mount this topology. To do that, he gets the parameters I've showed you and go to the right file. In this case, we have 60 flows and 100 Mbps rate. So it goes to this file here, 60 client, 60 server, and 100 mega MB. So let's take a look inside this file. So as we can see, we have the first line for above the lines. We have the comments. The first line refers to the bottleneck. So we have 10 milliseconds and 100 megabyte data rate. The following lines refers to the links between the terminals and the routers. The first 61 is the connections to router 1. The 60, as we can see here, as I'm showing to you here. The first one linked to router 1. The next one, 2 milliseconds the delay of these links, and the next ones, the 60 next ones, is the connections to router 2, where we have the servers, as we can see here. 10 milliseconds, okay, of delay, and 1 gigabyte. Again, this is the delay of the bottleneck, 10 milliseconds, as you can see here. Okay, great, that's good. Now we are going to take a look at how the connections are established, how Traffic Analyzer establishes the connections. It uses this file here, as we have 60 flows. Let's take a look. As we can see, you have the terminal 0 connects to terminal 60. Okay, terminal 0, terminal 60, terminal 1, terminal 61, and so on. Okay, until we establish all connections. So on the left side, we have the clients. The left side here, terminal 0, 1, 2 through 59 to 59, and the right side, we have the terminals where we have our servers corresponding to right side of router 2. Okay, this is the connections. Terminal 0 links to terminal 60. We have these 2 last numbers here, but don't care about that. We are not using this number. But if you construct a file from scratch, model flow file from scratch, you have to put this suffix to everything works well. Okay, see you next video. Thank you a lot.